Hi and welcome back to yet another day, and we'll keep working on the weather forecast app. So yesterday we built the front-end interface, which is this one in here. Currently though, the functionality of this is limited, so all we have is some fake data in here in the plot, and then we have this select box, and then we have this slider, and then we have this text input, which currently is not active. So whatever you enter here, you press enter, nothing happens except of this being updated with the value of that. So today we're gonna be working on getting actual forecast data from a free weather API. So when the user searches for any place here, any city, any town name in the search box, they will see the data plotted in here for the next number of days. Yeah, let's do that. I'll see you in the next video. Thanks. Hey, welcome back. In this video, we'll continue building our weather forecast app. And so far, we have this code. This is what we wrote in the previous day, yesterday. And so this built this front-end interface in here. Now it's time to write the backend part. So that's what we do usually. We write the front end and then we write the back end. Now, to write the back end, you should think of the front end. You should keep the front end in mind. So try to find out what input is the user sending from the front end. What kind of input data? So these are the place, which would be a city name, a town name. So first is the place, then we have the forecast data, the forecast days, which could be 1 up to 5 days. And then we have the string temperature or sky. So these 4. Now that you know what input data the user is sending, that means you can go to your project, create a backend file, .py, any name. So the idea is that we're going to split the code of the backend from the front end. Main.py contains the front end, backend.py contains the backend. And now here you can write a function such as get data, define get data, and write the arguments here, such as place. So we had the place, days, or forecast days, if you want to be more explicit. Then we have, let's call it the kind, or the type of weather, or whatever you want to call it, that variable. And yeah, that's what we have. So this function will expect these values. So the user will enter these values from the front end, right? Place, days, and the option. And this front end will call that function. So let's delete that get data now and import from backend import get data, right? That's the name, get data. So make sure that main and backend are in the same directory for this import statement to work. So now we can call get data somewhere to get the actual data. So the data will be the output of the get data function. So get data will have the place in the correct order, days, and option. So that means these values will be passed to this function, and the function now should get those values, and it should query the actual forecast values from the weather API that I'll introduce you in just a bit. And then the function should return the data here. So those data are going to be stored in this variable, right? So we don't need that as well. Or maybe we'll need to do something like this. We don't know yet. So perhaps it will be something like this. We'll see how we will construct the data. But for now, this is like a rough overview of the code. So let's now get the actual data from the API. Before I started to write the front end, I did some preliminary research. I googled around to see what APIs offer data, forecast weather data, and I found out openweathermap.org. So before you write the front end, you should have a clear idea if you actually have data or not before you start to build the app. So make sure that you secure the data first. And that's what I did. So I looked around and I found this service. And this gives you free data for 5 days. Let me explain you exactly how these data will look like and how you can get these data as well. So please go to openweathermap.org and then go to sign in. Here you can create a free account by going to the create account link there. And once you create an account, you can sign in this area here. Once you sign in, you want to go to API, the API section. And there you have different services that this API offers. The service we will be using is the 5-day, 3-hour forecasts. So please go to the API doc, and there you have this table of contents on the right. The link, the endpoint we're interested to get is the built-in API request by CTID. So that's a sample API endpoint, a URL, which we'll be using. So please copy that and then go back to your backend.py file. And inside the function, make sure to indent and place that URL. So this will be a URL, right? In quotes, so make sure that this is well formatted. I have to go back here, API key. So it's quite badly formatted. Make sure these spaces shouldn't be here. That as well here, no space, no space. So make sure to remove all the spaces in the URL. Yeah, that should be fine. So this URL, what will give us is, it will give us JSON data for any CT, and these data are temperature data and other sky conditions such as rain or sun, etc. These will be the data for that city for the next 5 days at an interval of 3 hours. So now we need the API key, and you can get the API key from your username. Click the username here and then go to my API keys and copy that key. I'll place the API key as a constant here, a variable outside the script as a string. And so then API key should be that variable, right? So replace that to that. So this has to be an F string now. CTID will basically be the place. So remove CTID with the place. Plus here in front, before API, you should have HTTP://. And let's get this this URL and try it on our browser. So like that, but replace the API key, including the curly brackets, replace it with your API key, and also replace the place and the curly brackets with a city name. Let's say Tokyo. Press enter. And you should get a dictionary. This is an error, because I got the wrong API URL. So we should have gotten the by city name, which is this one in here. So copy that and place it in here. So that's the place and that's the API key. And I'll copy that again without the quotes. Place it here. So this URL is slightly different from the other one. Let's try Tokyo again. And the API ID, so the key is this. Place it there. So make sure your URL is the same as mine. Press enter. And yeah, these are the data. Now let's get the same data from Python. And to do that, you need to import the request library. If it's not installed, make sure to install it, and then do response is equal to requests.get, ask for the URL you have here, and the content will be response.json. So these are JSON data, therefore we apply the JSON method. Then let's return the data, the content, whatever variable this is. Let's call it data. Data here, data there. And then call this function if name is equal to main. You know this, I've explained this a couple of times, this conditional block. So it makes sure that this getData call is only triggered when we are executing the script directly and not when the script is being imported from somewhere else. So getData, and the place is going to be equal to Tokyo. Now the other two arguments. For now, let's just place them a non-default argument for now, so that we don't have to call them in here. Yeah, I'll run the script backend.py, and let's actually print out the data, otherwise you'll get nothing here because nothing is being printed out. We return them but we don't print them, so this will print out those data. And yeah, we actually got some data. And that ends this video. So what we did so far basically is that we created a function here which returns some data. These data are still the raw data, so we're going to get the number of forecast days that the user wants here, and we want to return only the data for that number of days. We'll do that in the next videos. And we also want to filter the data again by the kind of weather condition the user wants, which could be temperature or the sky condition, sunny and rain, etc. Because currently these data contain many types of variables such as minimum temperature, maximum temperature, pressure, and also here is the clear sky, etc. So there's where we stand right now. Now, meanwhile, before you play the next video, I do recommend you to try to understand these data. You can either view them in here in the command line, or you can view them in the browser, or even better, you can place just here a breakpoint and then right click and go to debug. That will stop the execution at this point, and you will see this variable, the data variable, here in the debugger pane. Then if you expand this, you're gonna see all those keys of the dictionary. The one we're interested about is the list key. So the list key can also be seen in here, that's the list key, and its values are a list of different dictionaries. So that's the values. So each dictionary, third dictionary, fourth dictionary, dictionary, and so all these are weather data for at an interval of 3 hours. So please try to explore this even further to understand the data. That's very important. And I'll see you in the next video. In the previous video, we were able to query this URL and get all the data of that URL. The data looked like this. Now, in this video, instead of returning all the data, we only want to return either the sky conditions or the temperature values, depending on what value this kind parameter will have. Because as you remember later on, the user will enter the option in the select box. They'll select either temperature or sky, and that option is going to be placed in here and then in here. So that will be either temperature string or sky string. Also, we want to filter the data based on the number of days. So the user will select in the slider either 1, 2, 3, 4 or 5, and that number is going to be placed in here. So we will use that number and that string to return only the filtered data based on those values. To do that, we need an understanding of the data. And as I showed you, a good thing to do is to put a break line just before the line where you construct the data variable in here, and then right click and go to debug backend, and then go to the data. Now, in the console tab, which you see in here, if you write data here, the name of this variable, data, you'll see that you have access to that value, to that variable. So you can use that data variable. Basically, we have entered inside this function now, and so we have access to a Python interpreter of that function, and that interpreter have access to all these variables, local variables of that function, the URL as well. So you see it's a string and so on. That means instead of trying things out in the Python script here, trying to extract the values, we can work in here. So we can say, for example, perhaps data list will give us some values. Yes, so there we go, because data list, as you can see, gives us the value of the list key, and the value is a list of several dictionaries. So a list of several dictionaries. So now I can go here and say filtered data is equal to data list. So that now is this thing in here. So we can take this step by step, and then so we can grab that variable in here as well. Filtered data is equal to that. And now what do we do with this filtered data? Well, let's check the length of this. It's 40. Why is it 40? Well, because the data are at an interval of 3 hours. That means for 24 hours we have 24 divided by 3, we have 8 data points, right? So 8 for 24 hours, and we have 5 days. So 8 times 5 days, that means we have 40 observations. So that is for 5 days, right? 8 values for 24 hours, 40 values for 5 days. Now, what if we want the forecast for the next 24 hours, or for the next 2 days, so to say? That would be 8 times 2, right? So basically, we're gonna have this forecast days given by the user. Let's say this will be 2. In that case, we will need a number of values which is equal to 8 times 2. So we will need 16 values. So that means we can filter the data even further, and we can say filtered data is equal to filtered data from the first day to 8 times forecast days, right? Filtered data. So filtered data now is going to be that list, and the length of this is 16. So for the next 2 days. Yeah. So let's do that code in here. So step by step, we try things out in the debug console and we write the codes here. That's what you do when you have these complex data, complex programs. So you should leverage the power of the debugger tool. So the number of values variable is equal to 8 times forecast days. So the value that the user gives here is going to be passed in here, and then filter data. Let me copy that code. That will go in here, or well, this is actually number of values, so we calculated that in here, so we replace that in here. So from 0 to number of values. Right, so we were able to filter the data by forecast days. Now let's try to filter the data by the kind. So either sky condition or temperature. We return either one or the other. So if we look at the data, we're going to see that each of these 16 dictionaries, so that's the first dictionary, it starts there, it ends somewhere, you can also see it in here, so that's a first dictionary, second dictionary, and up to 40. We're going to have only the first 26, for example, but each dictionary has keys dt and values main, and this keys dt and values, so that's the date in another format in seconds from a reference point which was somewhere in 1970s, and from there we have the seconds. So that's a format, a date format in these kinds of integers instead of normal dates. Anyway, that's another issue. Then we have this key main, so you can also expand this main, and the main key has this dictionary with data. So now in the code we say something like if kind is equal to the temperature string, so that's a string that the user will enter here, right? Either temperature or sky. So make sure to reflect either of these in here. You can also use a match case block, but I'll go with an if-else conditional because it's just two conditions. So if kind is equal to temperature, then filtered data will be filtered even further. How we do that? Well, let's go back to the console. So from filtered data, there are different dictionaries, but let's say from dictionary with index 1, we want the main key, so that value of the main key, and from that, so that's gonna give us this dictionary, right? That dictionary, and from that dictionary, with the upper arrow key, you can call previously executed statements. From that dictionary, we only want temp. That should give us that value. But that is for only one dictionary, right? So what we need here is a list comprehension. So filtered data was a list of dictionaries. So that's filtered data, right? So we need to iterate over that list, over those dictionaries. So we say something like dict, just a variable. So this is a variable, dict main temp for dict in filtered data. Let's try this. Just the expression without the variable to see what we get in the console. So that's what we get. That's the list of all 16 temperature values. So that list will be stored in the filtered data, and then we will finally return the filtered data in here. Same goes for in the case of if kind is equal to sky. we have to do something here. So filtered data, in this case, is going to be, well, the sky is stored, so that's filtered data, right? And sky is actually stored in weather, not in main. So for that, we're gonna have to do a dict weather. And then after weather, we need this value. So that value is associated with the main key. So after weather, we do main for dict in filtered data. So let's try this expression in the console to make sure we're doing everything okay. So we've got an error here. List indices must be integers or slices, not strings. So let's have a look at the data again in here. Yeah, in filtered data, which is here. That's the original filtered data. So we have weather, but weather is a list, and this list contains this dictionary inside. Therefore, in weather here, you should extract this dictionary by placing that 0. So it's a list, and the list has only one dictionary, and we get the dictionary, and then out of the dictionary we extract the clear value using the main key. So that's the difference here. And yeah, let's try this again in the console. Yeah, now we get 16 sky conditions, right? So that's what this function is about. We can stop the debugger, and that's the complete code for the function for now. So we are able to return either the temperature values or the sky given the forecast days. So let's give it a try by entering here in the call, in the function call. Let's enter forecast days 3 and kind is equal to temperature. Of course, these are going to be provided by the user, by the front-end interface, but we're just testing things out now. So let's try this. And yeah, that's what we get. So we get the temperature for the next 3 days. So I suppose this has 24 values, 24 temperature values for the next 3 days, starting from the dates of the day, whatever it is. So that was about filtering the data. It was quite a complex data structure, but you also need complex things to learn even more. Before you do anything else, please don't forget to commit the changes if you're using Git. I'll not be committing anymore on video because you know now how to commit, so I think that's unnecessary to do it in video. So with that, thanks a lot, and I'll see you in the next video where we'll do some more coding. See you. As you know, so far we had this function which returns either temperature data or sky conditions as a list. So in our main.py file, we're going to call that function and get either temperature or sky condition data. So basically in our main.py file, we have these title, text, input, slider, select box and subheader widgets, and then down here we get the temperature or sky data, and then here we create a temperature plot. Now we should create a temperature plot only if we get temperature data, but if we have sky data, we're going to show some cloud and sun and rain icons instead of showing a plot. Remember that I showed you how the app looks like in the very first video of this app when I introduced you to the app. So with sky, we are going to render some images, and with temperature, we're going to render a plot. That means in here, we should have two behaviors. Either one should happen or the other. So st image is what we'll need to use basically. And then inside this image method, we will provide a list of image paths. I'll give you the images. Anyway, what I'm trying to say here is that we have two different scenarios, and for that we need an if conditional here, which should check if option is temperature. So if the user selects temperature in the select box, then we will generate a figure, a plot object basically, and plot that figure in the web app. So if option is equal to temperature, and if option is equal to sky, then we're going to render images on the web app. So that means we should have the if conditional blocks in here, as I just did, instead of having them in here. Because let's suppose that we have them in here. In that case, this will be either a list of temperature or list of sky conditions. And in that case, still we would have to write another conditional block here to check if the data are sky conditions or temperature conditions, right? And do something depending on that. So why not just remove these conditionals from here, and actually we get this filtered data, and we do that filtering in main.py. So in this temperature conditional block. So filtered data, same for the sky conditions. Get that, go here, down here, filter data is equal to that. And then in here, we remove that as well, and just return the filtered data. So we have filtered the data here by extracting only the number of days that we need, forecast days, but we'll not be doing any filtering based on the option that the user chooses. So remove that kind argument, remove that as well, and now we need to call this function from here, get data, with place and days, but not with the option. And we can store this in a filtered data variable, and that has to reflect this here. So make sure that this variable is the same as this. So we get the data filtered by the number of days, and then we filter them further in here by temperature, or in here as well by sky conditions. Right, and then we plot the figure, but the figure needs the dates as well. So we need to plot the dates horizontally in the x-axis and the temperatures vertically in the y-axis. So this will be like temperatures, and temperatures is this list. So we already extracted the temperatures, right? And we need the dates. So dates will also be a list comprehension in here. So we will get a list of dates and plot it along the x-axis. So what can we place here in this dates? Well, that would be something like dict. You remember there was a dtxt key in our data. So for dict in filtered data, that should give us the dates. So yeah, let's run this app now with Streamlit and see where we have gone so far. So Streamlit run main. We're gonna get an error. So that's the error I was referring to, key error list. And that is because we're not providing the place here immediately. So when the script runs for the first time, place is empty. Therefore, we don't get data for that empty place because they don't exist for empty places. And therefore, if you place here a city and press enter, that error should go away and you should get the actual data. So these are the temperature data for Tirana for the next few days. Right, so how do we fix that list error so that it doesn't show when the user loads the app for the first time? Well, you can do that quite easily actually. So we only want to get the data, we only want to call that function, in other words, if place. So, which means if place exists as a string. So when the user doesn't provide a place, place will be an empty string, right? So we are in this situation. When the user loads the app for the first time, place is an empty string. And we say for if place, print yes. Nothing will be printed out because this is not evaluated to true when the string is an empty string. But if place is something, then you say if place print yes, then you get yes. So that's what we're doing here. If place is provided, then we're going to be getting the data and we're going to produce that figure and plot it, and the same goes for the sky conditions. So now let's also complete the sky conditions, because currently if we go to sky, nothing happens here. It says that image is missing one required positional argument image in here. So here we can provide a list of images and that will generate multiple images. So you can provide either one image, with image I mean the path to an image file. So either one image path or multiple image paths as a list. So we need some image files to represent those sky conditions on our web app. And for that I've prepared some PNG images, so please download these from the lecture resources. And so that then place them in a folder such as inside this images folder, and then paste that images folder in your project directory here. I'll add them to Git. So now images contains these 4 PNG files, and images should be in the same directory with main.py, so in the root directory of your project. Right, so we should work on this if conditional block here. So basically these are sky conditions, right? We did that in the previous video. Let's see how these this list looks like. So I'm running the app currently, so I'll reload the Streamlit app, provide a city name, press on sky, and now we get this error because of this line. We haven't finished this line yet, but before Python finds the error here, it prints out the sky conditions in here. So that's a list of strings. So we have clear, clear, clouds, clouds, clear, 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 etc. And basically we have those 4 conditions as you see in the images: clear, clouds, rain, and snow. So we need to count for all of them. And basically we need to create as many images as we have conditions here. So for example, this query was for 1 day, but if I change this to 2 days, then we're going to get a longer list, right? Now it's a longer list of sky conditions for the next 2 days. So the number of images should be the same as the number of conditions. So 1 image per condition. So we should figure out a way to go from this list. So from this list to something like this: images clear.png, images clear.png, again images cloud.png. So for each condition we should have one image path. So that corresponds to that, that corresponds to that, and all these image paths should exist in your project directory. So you see images / clear.png is here in my project. Same goes for images cloud.png. So how can we translate that to that? Well, there could be different ways to do that, but a good solid way is to have a dictionary where we have the paths of the images associated with the conditions. So the conditions can be clear, and that should be associated with images / clear.png. Then we have clouds with S at the end. That should be associated with images cloud.png. Then another one is rain with capital R. That is associated with images rain.png. And then we have lastly snow, that is images / snow.png. So that's a dictionary that you should also have in your code somewhere in here. So execute that in the console perhaps to see if you have the syntax correct, and it's fine in my case. So once you have these images and you have this list, then you need to construct another list where you have only the image paths corresponding to those lists. So this is also known as translating the data. There are different ways to do this translation, but one way is to use a list comprehension. So basically you'd say, give me from images, give me the condition for condition in strings. Let me explain what this does. So for each condition in this list, named strings here, this is named sky conditions. So for each of those strings, we're going to extract the value from this images dictionary. So basically, this will be like a loop. In the first iteration, clear will go to this place, and so that will extract this path. So this path will be stored in this list as the first item. Then in the second loop, again we have clear, so we will have a second images clear.png item, so 2 items in the list, then clouds, and so on and so forth. So if I execute this now, that will produce this list of image paths: images clear.png, images clear.png, images cloud.png, and so on. So let's have this same code in here as well. Let's call this image paths is equal to images. So that variable, which is a dictionary, from that dictionary we extract condition, which is just a variable that we create here on the fly in this list comprehension. So for condition in sky conditions, right? So this will be that list. So for condition in sky conditions. And then we plot the image paths in here. Let's see what we've got in the front end. Tirana, that's the temperature. What about sky? Yeah, it's working. So we have 2 clears, 1 cloud, two clouds, another clear. So that reflects that clear, clear, clouds, clouds, clear. But we have an issue with the size of the images. That you can fix by providing a width of, let's say, 115. Reload. Sky. Yeah, now it's working fine. Let's change the slider to something else. And yeah, the sky conditions are updated based on the slider here. If we go to temperature, this is working based on that slider. And yeah, that's about it. It was a very long and complex app, but complexity, as I mentioned before, is very good while you are in the learning process. So thanks a lot for following this app. I hope you liked it, and I hope you learned a lot with data structures. Especially, we did a lot of data structure manipulations here with dictionaries and lists and etc. Thanks a lot. I'll see you later. Hey, welcome to today's exercise. This exercise consists of fixing two issues with the weather forecast app. The first issue is that when the user enters a place, the graph shows the temperatures in degrees Celsius but multiplied by 10. So this is 294. You should display the numbers correctly, so that would be 29.4, 29.2, 29, etc. So please work on the code so that these values are displayed correctly. That's the first issue you need to fix. The second issue is that if the user enters a place name which does not exist, for example this name, Tirana X, and they press enter, the user will see this error. Now this is not user-friendly. You shouldn't show errors, code errors to the users. You should display them messages to explain them in simple words what the problem with the app. So in this case, your task is to display here a message which says that, oh, you entered a non-existing place. So display a message like that in here instead of this error code. And that is the second issue you need to fix, and in the next video I'll show you my solutions to fix those two issues. See you there. Hey, in this video I'll show you my code solution to the two issues I described in the previous video. So let's see the first one. The first one was that these values should be divided by 10. That's very easy to do. All you have to do is go to this line 19 where you extract the temperatures and just divide this by 10 basically. So that's the list comprehension, and this here represents each temperature value. So we are dividing that by 10 and storing each value in the list comprehension. That was the first issue. The second issue was that when a city name or a town name which doesn't exist is entered here, we get this error. So this happens in line 16 of main.py and line 10 of backend.py. So in main.py we should somehow have like a try except block, and the try except block should wrap this code, this line where the error occurs in main.py line 16, right? Line 16. So we should try this line where the error occurs. We should try to execute that line and the other lines as well. So if this goes well, then we should execute the other ones as well, right? Which is to show the temperature in the plot or the sky conditions. Otherwise, we say except here key error. So that's a key error, right? Key error. And except should be indented with the same level with try. So try and except are at the same line. And then we say st.write that place does not exist. So with that, I'll rerun the app. So just write something, a place that doesn't exist, press enter, we get this. Place does not exist. And if the place exists, like Tokyo, then we get the plot with these real temperature values in degrees Celsius. And that's about fixing those two issues. Thanks for following, see you later.